All right, y'all, let's get right into it. This is saving Snapchat memories using Python. So quick overview before we start. Quickly cover what we're going to build. We'll take a look at how we can get the Snapchat memory download URLs. And then we'll circle back to merging memories when we get to that point in writing our code. So what we're going to build is a tool that does three things. It's going to generate the download URLs from the memorieshistory.json file that you get when you request your data from Snapchat. From those URLs, we'll download all of our Snapchat memories. And finally, we'll merge any fragmented videos into one. I know we all love saving longer than 10-second Snapchats. And when this is the case, Snapchat will actually save that specific memory into 10-second chunks. So we'll need to add some logic to go through all of our memories and merge any videos if necessary. To download your data from Snapchat, navigate to the home page and hit the top left button to get to your settings. Scroll all the way down and click the second to last option called My Data. After doing so, you'll be prompted to sign in one more time to your Snapchat account, and then you'll be brought to this page where you scroll all the way to the bottom and you hit the yellow button. After some time, you'll get an email with a link where you can download a zip file to all of the data related to your Snapchat account. After some time, you'll get an email. Click that link in the first paragraph. You'll be brought to a login page where you just enter your Snapchat information one more time. And then in the Your Data is Ready section, just click that link to download the zip file. One more thing before we start programming, which is let's cover how we get these download URLs from Snapchat. If you take a look at the zip file that you downloaded when you requested your data, things should be arranged like this. There's a JSON and an HTML folder. If we go into JSON, a lot of stuff in here. But what's most important is this memorieshistory.json file. And we're going to use the data in here to download all of our memories. Now looking at the contents, let me switch over to Visual Studio Code. I have this file opened up and, it's just a JSON file with date, type, and the download link. Now if I go ahead and try and open this download link, it's a little misleading, which is kind of annoying on Snapchat's part, because when I open this and I take a look at the Chrome output, it says, get is not supported by this URL. It's like, dog, why does that say download link? And I click on it and then it doesn't work. So that's a little misleading. There is a solution to this, which we can cover in the next slide, where let's say on the left side, that's us, the programmer, and on the right side is Snapchat. We take that URL that we tried to click on and it didn't work. We send a post request, HTTP post request to Snapchat, and Snapchat will respond with a S3 link to the actual memory. So what we'll do is we'll iterate over the JSON for every URL there is. We'll send a post request. Snapchat will respond with the real download link, and we'll just keep track of that for when we want to do the next step, which is downloading everything. Okay, let's do our first step, which is going to be taking those download links that were given to us by our Snapchat data, and we will grab the actual download links from Amazon. So I have a folder created and opened. I just called it Snapchat Save, and I opened it in VS Code. And I have one file in here, which is from the zip. As shown before, it's the memories history. And you might have, hundreds or even more memories. But for now, just to keep things simple, I have about, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 memories. Cool. So first file, I'm just going to call it generate aws.py. And in here is going to just contain the logic for going through those download links, like I said before, and grabbing the real download links. As we said before, that was pretty misleading. So start with some imports. So I'm going to need JSON. I'm going to need the requests library. Let's see, what's this? Okay, just VS Code being slow. We're going to also need sys, and I'll say why later. It's just for printing to help us keep track of what's going on. So I'm going to define things as a class. Just call it AWS Link Generator. I love making classes, so that way you can import them. Generator, there we go. So two class variables I want to keep track of is going to be AWS links. And then I'm also going to do memories data. And it will all make sense in a moment why I'm doing this. So for now, let's do a constructor. So Real simple. Just takes one parameter self. Let's take one more, which is going to be the path to the memories.json file. Does that make sense? So the user can supply where that memory file is, and then we'll just assign self.path to JSON to this parameter, and use it later. Okay, cool. Now, let's do two more functions. So we're gonna do loading the JSON. We're gonna make use of that path to JSON variable, and we'll in here we'll load JSON. But I'll just put pass for now. Let's also do one more function that we need, which is gonna be for generating those download links. So I'll just call it handle link generation, and we can use all the parameters that we've already sent, which is just one. So we don't need any other parameters here. Just do pass. Okay. Nice. Now down here, I'm gonna just add an if statement. This is outside of the class, and this is just to see if we're running the script directly. So if name is main, I'm sure you've seen this, very common if you've written Python. I'm gonna define a object called link generator, and it'll be the class. And what we'll send in is this memories history.json file, right? So let's do memories history.json. The link generator needs to load the JSON, and then the link generator will go ahead and get those download links that we really care about and really want, obviously. All right. Now that that's done, we could run this real quick and just see how it goes. So I open a terminal within VS Code, and I'm just going to run python generate.py. Obviously nothing happened. It's good just to double check. All right, let's put that terminal away for a minute, and let's build out this load JSON file. So we're going to use with open self.path to JSON as f. Now here's where we're going to use our first class variable. It's going to be the memories data. So this is just going to be the real, containing the JSON values from the memories history.json. So self.memories data equals, we can use the JSON module for this. So json.load and then f. Very, very simple. That's it. We're done with that one. And let's do this handle link generation real quick. So let's see. What we'll do first is, let's just comment out what we want to do. So I'll bring back this pass for now, but let me just comment out what we want to do. So iterate over download links. I know that's misleading. It's the download links from this JSON file. So we'll iterate over all these first. We will send a post request, get AWS link, and then we can save the link to the array. I forgot to mention this. We'll define an array up here. Define an array to hold real download links. All right. Iterate over, let's just say snap. I'll just change this to say iterate over Snapchat JSON, and then at the end we'll just say write the AWS URL array to a different JSON file. So we won't download it. This class is only going to be responsible for getting the links and then just saving them to a file. We can download them in another step. All right, so let's just do this first comment really quick. So we'll just do AWS URL list empty array, and then if you take a look in the memories history, there's this field called saved media, and then it's an array. So we need to access this field and then iterate over everything inside of saved media. So we'll do for, let's just say memory in self dot memories data, and then the key here is going to be saved media, like that. All right, so as mentioned before, we're going to iterate over the Snapchat JSON right there. And we need to do these two things, which is sending a post request and then saving that link. And we can use the request module for that. So I'll just create a variable called response. We'll do requests.post. Now keep in mind that memory is going to be an element, for every element in this array. And the fields that, a certain element has are 3. So it's date, media type, download link. So we're going to use this, obviously, because we need to access this field to get the real download link. And so we'll do request.post, we'll do memory, and then download link, just like that. All right. And the response is going to be in bytes, but we want to decode it to something we can understand and work with. So we'll just do response.content.decode, and then we're going to decode it to UTF-8. All right, and once that's done, we're going to need to append the URL value to the URL list. And I think some important things to know here are what we want to append to this list. So we're going to need date, let's say file type, because you won't readily have that available. And then you're also going to need the AWS link, obviously. And we'll save it to the array. So let me move this up. So we can let's just print the URL right now, and then let's just go for it. So I'm going to bring back the terminal, and I'm going to run it again. Nice. So you can see that it's running for every element in the array, and we're getting a response back, which is like HTTPS, US East, AmazonAWS.com. And then you can see over here that on the second line where my mouse is, there's a .mp4. You can see .mp4. So that's where we can get the file type from. And the date is already in the JSON array. This doesn't look very pretty. It looks like a lot of, text. It's kind of hard to read. But we're going to need those two things to move on to our next step, which is going to be downloading. So we can do something like this, where we go AWS, URL list .append, and then we're going to append a dictionary, which you can do with curly braces like that. So first one will just be date, which we already have, which is just memory, and then date. But one thing I want to get rid of is this UTC, because the problem with that is when we're going to parse the date later, this added string here is not really part of any date information. So let's just do a substring where we omit the last 4 characters. As you can see, the last 4 are consistently UTC across the memories. So back here, we'll just do square bracket, and we'll just do len memory date again. This is the date field, obviously. Sorry. And then just subtract 4. That's it. Cool. Now the next field is our file type. I'm doing camel case because it's JSON, like why not? Let's actually handle this file type in a separate function. So up here I'm going to define a new function. We'll just call it get file type. It takes itself as a parameter because it's a class method, and then let's just say file URL. And what we can do is just a little bit of magic with the string. So we can split it by the question mark, because if we go back to that output down here, let's see, it's HTTPS, prod, memories, blah, blah, blah. There's no question mark. If you saw my JavaScript API video, I talked about how URLs are formatted, but we want everything before this question mark because we really want to just get this value right here, this MP4. That's what we care about. So close this up, come back here, and let's just define another variable called URL. I know that we did it right here, but it's okay. It's in a separate function. And we'll do file URL. So we're going to do file URL.split. split it by the question mark, remember? And then just the first element of that split because it returns an array. And then after that, remember that we need to access, let's go back to the terminal. We need to access everything after this dot. And this is going to be the last dot no matter what. See how it's always .mp4 or dot whatever? I think there should be a JPEG in here. Yeah, here's a .jpeg. But we know that the file type is going to be after the last period. So with that knowledge, we can just do return URL. We'll do one more split. We'll split it by the dot. And to get the last element in the array, just do -1, really simple. All right, so now we can make use of it down here, self.get file type, and we'll send in the URL. And the last thing we'll do is the AWS link, and we will do the field AWS link in camel case, and we'll just map it to URL. So there you go. All right, so now that that's done, I got rid of that print statement because that cluttered things quite a bit. We just need to, we've already saved the link to the array. All right, so let's move that up here. Just flip those. So now the last step is writing the AWS URL list, right, to a different JSON file. And that's really, really easy with this JSON module. So we'll do another with open. I'm just going to call it AWS links.json. And you need one more thing, which is the right specification as a W. And we'll just call it like output. And then we'll just do json.dump AWS URL list and to the output. There we go. Let's format this little cleaner and let's run it again. Ready? Here we go. Okay. Any minute now. There it goes. All right, and there you have it. Right here, if I make this a little smaller, you can see that this worked perfectly. We have our file type, and we have our actual link that's going to take us to download this. Let's do a quick example. So, for example, if I open this one in Chrome, I just control-clicked it from VS Code. I'm going to open this.
Heat rises, right?
There you go, there's me. And there's a Snapchat memory I have where I was trying to do a science experiment with a lighter. We could watch that at the end. But you can see it works though. We didn't get that method not supported or whatever we got earlier. Awesome. Now, if you have hundreds of memories or even more, which I do, I noticed that this step takes a very long time. So if you want to just make sure that things are going, normally and not, things aren't stuck, what we can do here is let's just create a variable called count. It's like really, really easy programming here. Just have a variable called count, and we're going to use that sys module that I talked about earlier, and we're just going to do sys.standardout.write. And what we'll do here is we're just going to do f string, so we'll just say finished, let's just say count, divided by, and then we'll do the length of the memories data. We'll just do the length of this right here. Keep things simple, So what's happening here is it's going to print, let's see, did I mess up somehow? Oh, right, you can't do this. You know what? I don't even care. I just want to see how many we finished. Let's just do that. So finished count, and then I'll do a carriage return. And now this will look really cool when we run it. Watch. See one. Finished one. Oh, whoops. One thing I forgot, obviously. I was calling it easy programming and I messed up. Look at me. Let's add the count variable by 1. Count plus equals to 1. All right. So now if we really do it, finish 1, 2, 3, 4, 5, 6, 7, boom. So you can do that. And you can just have that running counter go as this program is running and generating those AWS links. All right, well, now that that's done, let's go ahead and move on to our next mission, which is downloading all these memories. All right, it's time for our second mission, which is going to be taking that generated JSON file and downloading our memories. I'm just going to call this download memories.py, and we're going to start with our imports. So we're going to import JSON. We're going to need OS, the OS library. We're going to need one more thing from OS, which is the path submodule. Path. We're going to need requests again. To speed things up, we're going to make things multi-threaded. Don't worry, it's not going to be anything too crazy. And then we're also going to use the concurrent module. So from concurrent.futures, we're going to import thread pool executor. This makes things really, really simple. Don't have to worry about locks, semaphores, any of that with that class. And then we're also going to import from that same module, we're going to import wait. And we'll use that along with our thread pool executor to speed things up, because downloading, hundreds of memories can be really slow. So as always, we'll define a class again. We'll call it memories downloader. Let's do a constructor. So def init. Not sure why it does that every single time, but oops. Make things a little prettier. All right. What are we going to take? I think we should take 3 parameters now, one being optional. The first one's going to be path2JSON, just like the last class we wrote, but this time it'll be the path to the AWS link, right? Because we're going to download from that. And the next one's going to be the download location. So this can be a folder, wherever this may be, and then the number of threads we want to run at once to keep things moving. So thread count, this is an optional parameter, so I'm going to just default it to 10. And really simple, let's just do self.path to JSON is equal to path to JSON. Same thing for download location, so self.download location equals download location. And then we're also going to do thread count. Thread count is equal to thread count, or threads count. I think we'll change this to say thread count. Keep that in mind for the constructor. Okay, great. 2 more functions I know we're going to need is going to be load JSON, of course. Very, very similar to what we had before. We're kind of violating the dry concept by having 2 of the same functions. We could definitely put that in a separate file if we wanted to. All right, what else we got? We're going to need handle download. And that will just take self. And this is going to be multi-threaded. So we're going to send in a parameter called memories list. And each thread will have its own unique list of memories to download. So we'll just say this is handled by threads. This is going to be used by threads, by each thread. There we go. All right, cool. We're going to need one more function, which we'll call from the main. That if name is main, I'll just call it download memories. Won't take anything here. Pass. I'll just say create threads. And then, great. Cool, is there anything else we need? I don't think so. All right, back in load JSON, you know the deal. We're just gonna do with open. We've done this before. Self.path to JSON as F. Then we're gonna do, let me get one more self. I'll just call this JSON data. Just be empty. And then we'll do self.json data equals JSON.load F, just like last time. No difference. Now, if we're going to have multiple threads running at the same time, we're going to need to split this JSON data into equal parts. And what we'll do is I'm going to do I'll just call this split memories for now. And it will be an array of arrays. and each element in this array, or in this list, is going to be another list, which will be handled by the thread. So let's say that we're going to have 10 threads, then there's going to be 10 lists in here that, you know, each thread will have respectively to download memories from to speed things up. All right, and now we're going to assign self.split memories to something. But what is that, you might ask? Let's add another helper function, which is going to split a list into n parts. So split into n parts. Self, we'll take the list, and then we'll also take, you know, the number of parts. We'll just call it n. And right here, it's going to be really, really simple. It's just some array syntax from Python. So we will do for I in range. So we'll go from 0 to the length of this list that we send in, and then n steps, since we're going to create n chunks. And then we can use yield, which is kind of like a return statement, but doesn't exit the function. So we'll just yield the list from the index I to I plus n. I forgot the colon here. Okay, so this is going to really, really optimize things by splitting up this JSON data into, you know, n parts, say 10 parts, so that you can run 10 threads at the same time to download things. Now, I do understand that I/O is blocking, but that's okay because they still need to download, and that can take time. So they'll have it ready to go, and I'll take turns writing to the disk. All right, so split memories, we'll just call self. Oh, actually, we need to cast this to a list. So do self.split into n parts. We'll send in the self.json data, and then the second parameter is the n here, so we'll do self.thread count. Okay, great. All right, so load JSON is done. Let's take a look at handle download. What can we do in here? So we're gonna need to do, this is gonna be run by threads. So we can just assume that memories list is just gonna be, you know, just an array of this, right? So we can assume that memories list can be, you know, some like subset, maybe like 2 memories, you know, out of the 11 that we have or something like that. So let's iterate over it. So we'll do for memory in memories list. Let's just do print downloading. Oops. Use an f string. So print downloading. Downloading, and then we'll do memory. Oh right, I forgot you can't do that. We ran into that issue before. So if let's just change this to be memory bracket date. Great. Just so we know as we run this. And then what we're going to do is we're going to need to do the full path to the memory that we're about to save. So we'll do file path, which is going to be path.join. So it's going to be self.download location, right? And then it's going to be an f string, because we're going to do, what we're going to save it as is we're going to save it as the date and then .jpg, or the date.mp4, if that makes sense. Cool. So I think one thing we should do is that later on when we do the FFmpeg stuff, the issue with saving a file name that has spaces in it, I've ran into some problems. So we can actually get the file name. Let's just go ahead and get the file name right now. So we'll do file name equal to file name. We're gonna assign it to the comma wrapped in a string. We'll do join And then in this parentheses here, we'll just do memory, the date field, we'll split it by the space. And that should do it for the file name. That's just the name. And then let's just append the type, obviously. .jpeg or .mp4. So file name plus equals dot plus memory. And then file type. Cool. I'm going to move this down here. And instead of saying downloading the date, let's just say downloading file name. Like that. Cool. Okay, now let's get a URL variable. And that's just going to be the AWS link field. So if we go ahead and do URL as memory, AWS link, we'll send a GET request to Amazon and we'll grab the data. So now I'll just assign a variable called response using that request library, request.get this time, send in URL. And then now let's open the file that we want to save it to. So with open file path with the WB mode, which means write bytes, just say F, and we'll do f.write response.content. Cool. And then we'll just say print finished file name. Cool. All right, that is our thread function done. And then now let's go ahead and dispatch these threads down here with these download memories function. So really simple. I'm going to define an executor variable. This is going to be an array. Oh, I lied. Sorry. This is going to be the thread pool executor object. Whoops. And then we'll just pass in self.threadCount. Remember, a thread count up here defaulted. You could do 3 or 10. My memories are small, so I don't really need 10 threads, but you can play around with this. See how fast things run depending on the thread count. Okay, cool. Now, let's do a futures variable. This is the array I was talking about. So executor. Executor.submit. And in here, we're going to pass in the function that we want a given thread to run. So it's going to be self.handleDownload. And then we're going to pass in a variable called memories. And this is list comprehension. So let me just do for memories in self.splitMemories. So this is going to iterate over these, arrays within this array, right? Since we split it up here into n parts. So based on each thread, we'll have some, subset of the total amount of memories, and then we will just dispatch them to download stuff. And that's it. All right, now let's do the main thing, as always. So if name is main, we're going to first initialize an object. I'll just call it memories downloader equals memories downloader. And what do we take? We take 2 paths. So let's just I'm just going to assign variables. Why not? Path to JSON equals AWS links.json. Say path to memories. And this second variable is going to hold the path to where we want to download our memories to. I'm going to create a folder called memories. I just had it there, but I'll just recreate it. And very simply put, this is just going to be /memories. Okay, cool. And then let's pass these in. So the first parameter was path to JSON, and path to memories is the second one. All right, memories downloader. Let's load the JSON, of course, and then let's download the memories. Oops, .download. Oh man. Great. Boom. All right, let's go for it. You ready? So come down here. Let's run this. You can see that each thread's printing downloading, finished, downloading. And we have threads running concurrently, downloading and writing to the disk. And I know that disk can be blocking, but the downloading part isn't, so that can speed things up. And what do you know? In this memories folder that we just created, here are the downloaded memories. The date is correctly formatted, as you can see. And if we open one of these up, let's go ahead and open this folder. All right, let's click on one of these. Oh, yep, there it is. Downloaded this memory right here. And like I said, we'll watch the full video at the very end. Awesome. All right, last part is merging these memories. Let's get right to it.